Today I am bringing you our lesson on inequalities live from my porch. Okay, so taking a look at inequalities today, a quick review of what each of these symbols mean. So take a moment and read through them each. We have less than equal to, greater than, and greater than or equal to. Secondly, a review of graphing these. So if you don't remember, when we just have a less than or greater than sign with no equals, it is an open circle on that number. So an open circle, and then it's going in this direction as our arrow points. Here we have an open circle and it's all numbers greater than, so this way. Number 3, we have a closed circle at 3. We also have a closed circle for 4. Because of this equal sign, it means that the number is included in the solution. Our line is going this way as the arrow points, and our line is going this way as the arrow points. So I'm going to erase these quick and then move on to the next slide. So hopefully a review. And our next slide, translating a sentence into an inequality. So we have a number b, and it is increased by 2. So increased is another way to say addition. And this is less than 15. Less than 15. Then we have a number x, which is subtracted from 10. So a little tricky, but it's actually written this way. So x is subtracted from 10. It's what we call a turnaround word. And this is greater than or equal to 10. Then we have the product of a and 5. That is multiplication product. Product is multiplication. 5 and a. This is the same as a times 5. And this is greater than -5. So translating a sentence into a inequality. Okay, so taking a look at these graphing inequalities, you can take a moment, draw these examples down. So what you want to do is we have x is greater than 3, so this is our x-axis, this is our y-axis, so I go to where x equals 3. The greater than and less than signs, so let me draw that down here, greater than and less than signs, when we draw the line, it's going to be dashed. We call this a dashed line. And then if we have greater than or equal to, less than or equal to, those are going to be solid lines. The dashed means that the number is not included in the solution. Here, the solid line means that the number is included in the solution. So here we have x is greater than 3, and it has no equal sign, so where x is 3, I'm going to draw a dashed line. And it's all numbers greater than 3. So this whole area we shade in is the solution. For the second example, we have x is 1, and it's a less than or equal to sign, so it's going to be a solid line at x equals 1. This is my x-axis, y-axis, and it's everything less than or equal to 1, so I'm going to shade in all this area. Taking a look in the y direction, I have y is less than 2, so since it's a less than sign, it's going to be dashed. That y is 2. And it's everything below, so everything below here. Then we have y is greater than or equal to -1, so that's going to be a solid line at -1, and it's everything above the line. So again, if you have the equal sign here, you're going to make it solid, and if you have the dashed, it's going to be the greater than or less than sign. Okay, taking a look at these two examples for graphing an inequality. This you graph just like a line, so I have at 4, I have the y-intercept 1, 2, 3, 4, so right here. My slope is -2/1, so I go down 2 and over 1. But just how we previously learned, if it's a less than or equal sign, our line is going to be dashed. So we're going to connect these with a dashed line. A dashed line. Now the question is, are we shading above or below? The easiest way to do this is to put a point in the inequality and see if it's true. So we have the point right here, 0, 0. So let's put that into our inequality. So we have the point 0, 0. When we put that in to this inequality, we have 0 is less than -2 times 0 plus 4. So this becomes 0 is less than 0 plus 4, or 0 is less than 4. If this is true, which it is, this is true, this point 0, 0 is a solution, so we shade all this in. These are all the solutions to this inequality. So let's do another one. Since this is new stuff, we graph this. -3 going up 1 over 2. And again, when I connect these, it's going to be a dotted line, a dashed line. And then you can pick a point. It's usually easiest to pick 0, 0. So let's see if 0, 0 is a solution here. So I put 0 in for y, 1/2, 0 in for x, -3. 0 is greater than 0 minus 3. 0 is greater than 3. Yes, this is true. 0 is greater than 3, so I shade all of this area right here. So a few more examples. Here we have x plus 1, so I can go to just graph it first, 1. My slope here is 1, so I'm going up 1 over 1. And since it is an equal sign as well, this is going to be a solid line. So greater than and equal to, less than and equal to, these are solid lines. Now the question is, which side of the line do I shade in? We have the point 0, 0 here, so let's test 0, 0. We're going to put 0, 0 into here. So we have 0 greater than or equal to 0 plus 1. Is 0 greater than or equal to 1? False. 0 is not greater than or equal to 1. So this is not a solution, so we're shading the top part here. Our second example, we have a point at -1. We're going up 2 and to the right 1. This is going to be a dotted line. And then we can test the point 0, 0. So we'll put it into the equation. We have 0 is less than 2 times 0 minus 1. 0 is less than 0 minus 1, 0 is less than negative 1. Is 0 less than negative 1? No, so this is false. So 1, 0, 0 is not a solution, so I'm shading everything below. These are all the solutions. Okay, so taking a look at a few other examples, let's say we have the equation y is greater than or equal to 2x minus 3. So again, taking a look at this, we have right here, orange. So we have an equals to here. That is why this line is solid, a solid line. And then you can put in the point 0, 0. So let's put in this point. According to this graph, if it's correctly, it should be a solution. This is all the solution area. So if we put 0 in, we have 0 is greater than or equal to 2 times 0 minus 3. So this is 0 is greater than or equal to minus 3. And yes, that is true. It is true. So that means 0, 0, and all these other points here, these are all solutions. So another example, let's do less than. So we have y is less than negative 1/2 x plus 1. Actually, let's make it greater than, greater than. So taking a look here, we have a dashed line because there is no equal sign, it's just greater than, so that's why we have this dashed line here. And then if this is correct, 0, 0 should not be a solution. So the point 0, 0, let's put that in here into this inequality and see if it's a solution. So we have 0 is greater than negative 1/2 times 0 plus 1. This all just becomes 1 is greater than 0. Or sorry, 0 is greater than 1, and that is false. So it is not a solution. So this 0, 0 is not a solution, which is shown here. All of this, these are our solutions here.